Unit 2B, Lesson 3. There's one standard we're going to discuss in this lesson. Derive the formula A equals 1/2 times A times B times the sine of C for the area of a triangle by drawing an auxiliary line from a vertex perpendicular to the opposite side. Previously, when you've talked about finding the area of the triangle, you've only worked with A is equal to 1/2 times base times height. Okay? Well, not all triangles are going to provide you with the base or with the height. Okay? So we can use trigonometry and come up with a few other formulas that we can use to find the area of a triangle. So if we have a basic triangle with angles A, B, and C, its side lengths little a, little b, and little c, there's a few formulas. They're all the same basic formula, but there's three different ones. First one, A is equal to 1/2 times AB, the side lengths, times the sine of C. Or we could have A is equal to 1/2 times AC times the sine of B. And the third possibility, area is equal to 1/2 times BC times the sine of A. So if we just focus on this first one to understand where these parts are coming from, A and B, if we look at these side lengths, A and B side by side, angle C is the angle between those two side lengths. So to use this area formula involving sine, you need two side lengths and the included angle. If we look at the second form, we have A and C. Angle B is the angle between those two side lengths, the included angle. All right, so these are the three we're going to work with now, because in this case, we have a triangle like this. It might be difficult to determine what the height's going to be. Right? So sometimes it's going to be easier to use this trig form. So what we're going to do next, go through and derive where this formula comes from. Now it's time to go through the proof for where that formula comes from. Again, if we just start with a basic triangle ABC, side lengths little a, little b, and little c. If we go back to the standard, we need to draw an auxiliary line from a vertex perpendicular to the opposite side. So I'm going to pick side B, and I'm going to draw a line perpendicular to this opposite side. And that distance, I'm just going to label that as h, our height. So looking at this right now, if we wanted to find the area, we have the base B and we have the height h, so we could go through and write the area is equal to 1/2 base times height. We know that's going to work. But now we're going to go through and use some trigonometry to show and verify where the other formula comes from. What I'm going to focus on right now is triangle BC, and let's label this point D. So we're going to focus on triangle BCD. Think back to SOHCAHTOA. The sine is equal to the opposite over the hypotenuse. Sine of C is going to be equal to h, which is the opposite side, over the hypotenuse, which is a. If I want to isolate this to get h by itself, I'd multiply a to both sides of this equation, and the simplified form is a sine C is equal to h. Some of you may recognize or see what I'm going to do next. I can substitute this equal value, a sine C, in for h, because we've shown those two parts, those two expressions, are equal to each other. Going back to this equation up here then, a is equal to 1/2 times b, which is our base, 1/2 times b. Instead of h, I have a times the sine of c. To make this look a little neater, I can rearrange two of the terms, a and b. So a is equal to 1/2 AB times the sine of C. This is one of the formulas we just talked about on the last side. Area is equal to 1/2 AB times the sine of C. So using a little algebra, we can rearrange and substitute to come up with this equivalent trig form. As long as we're given two side lengths and the included angle, we can use this formula. That's how to go through and derive where this trig form for the area of a triangle comes from. That's all you need to get out of this lesson. We could also go through using different side lengths, come up with the other two expressions or equations.